Hello everyone. So today in this video we are going to see a data engineering project I created. This is the project is analytics pipeline for YouTube trending videos data with AWS. So for this project I have taken the data set from the Kaggle. The data set contains the all the trending YouTube videos of last year, which contains their different different values of likes, dislikes, views, shares, comments, and dataset contains this dataset is region wise. There are different regions, and the region wise data is created. So there are different files in this dataset uh, for the, different regions, and for each region there are two files. One is the JSON file and one is the CSV file. So we have to create one single data catalog for this all the regions, or we can say all for this all the file, so that we can analyze that data with the help of some query tools or BI tools, and take some actionable insights from that data. So let's get started with the architecture diagram. This is the architecture diagram of the whole project. I took that dataset from the Kaggle and uploaded that data on the AWS S3 bucket. I named it as a raw bucket. So now we have to transform this all the data which we have got from this Kaggle. So first we will see how the JSON data is how the JSON data are transformed. So in this JSON data, first we have different values with their keys, uh, different keys with their values, and there is one items key which contains the different uh, all the data. No, so we want this only items key with their values. So to extract this items data, I created one Lambda function which extracts all the items from the all the regions of JSON files, and converts that all the extracted data in the Parquet Parquet format, file format, and stores it in a cleaned version of S3 bucket. We can see here, this is the uh, PySpark code for this function, which converts the extracts the items key from that JSON file and stores it in a S3 bucket in the Parquet format, file format. And there is I created one S3 trigger, means this S3 triggers when as soon as the data raw data is uploaded on the raw S3 bucket, this Lambda function gets triggered, and at and the extraction of that items and storage of these created Parquet files in the new cleaned S3 version of the bucket. After that, we are going to see the CSV data transformation. So in the CSV data transformation, we are going to change the schema of the data catalog which is being generated from that CSV file. So for that, we are creating one AWS Glue ETL job. So here is the Glue ETL job I created for this transformation. So this is the blue ETL job. Sorry, CSU to Parquet job, which this is the PySpark code again, and which converts these some uh, columns data types from string to big int or integer format. This was that was the purpose of this new ETL job. So after that transformation, that output of this ETL job is again a Parquet file, which will be again stored in this cleaned version of the S3 bucket. So now we have transformed this our JSON data and the CSV data uh, and created different Parquet files for the different regions and stored it in the cleaned version of the S3 bucket. So now we are going to from crawl on this all the cleaned version of the data. So for that we are going to use the Glue crawler, AWS Glue crawler, which scans the metadata of the whole the data on which we are crawling. So and it creates data catalog, or we can say tables um, for that data. So after crawling, it creates two different data catalog. Uh, Here we can see that two different tables are created. Uh, these are the two Parquet files created after the crawling, and now after now we have to join these two tables to get to query on this data set, table. So to for create one ETL, again glue ETL job, which that glue ETL job joins that two tables and creates two different data catalog, one single data catalog, and that that table or data catalog is again stored in a third S3 bucket, which will be our final and ready to analyze bucket. So now we have final table or data catalog on which we can uh, apply some analytical operations for the for getting the insights from that data. So after that, we are using AWS service, which is QuickSight, for the analysis of the data, which we cleaned from the whole transformation process. And this QuickSight service creates the actionable insights, or creates reports from that data. So here we can see the how that QuickSight service works. I created this uploaded that S3 bucket, accessed that cleaned version of the S3 bucket, and created these some insights. Here you can see these are the different reports or graphs which are created from that data. Here are also created. Here are the different visualization techniques which we using that we can visualize that whole data set. These are the different visualization techniques. So this is how this project I implemented using the whole AWS services. And here in this project, I also came across some different regions, and I faced some challenges, and implemented this. So the challenges I got in this project, that in this while running this AWS Lambda function, I used 3.9 version of Python, and in that 3.9 version, AWS Wrangler is outdated. So I got that error, and so for that I searched on the internet, and after that I got some solution that we can also use the mm, we can also use the AWS ESDK Panda library. So I used that Panda library and solved that error. This is how I solved and implemented this project. Thank you.